taking is GSS 1.
What subject are you teaching?
Basic science. So my name is at the end of the lesson, the learner should be able to say the percentage composition of air, oxygen in air, be able to perform experiments that shows that oxygen supports combustion. So I have an experiment. I had to, there's one experiment I had to perform before, but the instrument spoiled along the way. So I had to, that's what caused the delay. I had to have been here.
No props. We didn't know that, but you can keep going.
Okay. Let me try to mark.
Has our time started?
No.
I think. No.
Let me just.
There should be something that took place.
Aha! I was thinking so myself, but let's keep going while watching.
So this is the objectives: social material for the experiment, plastic bottle, candle, and lighter. So can I start the time now?
Please do.
Start your timing first. Come back. Yeah. Let's repeat.
Okay, class. I'm Mr. Olatunji. Now, the topic before is oxygen. Oxygen is an essential element in most combustion processes. Combustion means the burning of materials. Now, it's one of the most abundant elements in the Earth crust. Oxygen makes up 21% by mass of air that we breathe. Now, we breathe in oxygen, we breathe out carbon dioxide. You understand? We take in oxygen, we breathe out carbon dioxide. Now, the properties of oxygen. These are the properties. Oxygen is a colorless gas. That doesn't have color. Now it's an odorless gas. Now oxygen does not have any taste. Oxygen is a poor conductor of heat and electricity. Now we go back to the uses of oxygen. Some important uses of oxygen are as follows. Now oxygen is used by living beings in respiration. What is called cellular respiration. Without oxygen, when we eat food, there will be no combustion of the food we eat. That means we just eat the food. It won't result in energy. Now, oxygen is used for burning fuels. Now, oxygen in industry is used for cutting and welding and melting. If you go to any welder shop, there's what's called acetylene flame. That flame that comes out of the welder's strut is as a result of oxygen. Now, in industry, it's used for cutting and welding. Number 4, it's used in water treatment and chemical combustion. Now, we go over to the activity. The experiment to show that oxygen is needed for combustion, that to burn a material. Now this is our candle now. We need, for the experiment, we need a plastic bottle, our candle, then a lighter. So we lit the candle, then lit a candle, place a plastic over the burning candle. So what do you have? We wait for some meaning for what will happen to the candle wax. You see that the fire stopped burning because oxygen has been exhausted. The remaining oxygen has been used up by the candle in the confined space. Now this is because there is no more oxygen left in the space around the bottle. This proves that oxygen is needed for combustion. Now, do you have attention, class? Femi, what is the percentage by mass of oxygen in air? Any response? Okay, very good.
21%.
21, correct, sir, correct. Now, the next question, I want to go to evaluation. Evaluation now. State one property of oxygen. James, give us one property of oxygen. Oxygen is a colorless gas. Now, what do we breathe in and what do we breathe out? We breathe in oxygen, we breathe out carbon dioxide. Carbon dioxide is a byproduct, it's a waste product. We don't need it in our system. Now, for the assignment, perform the experiment at home to show that oxygen supports combustion. So that's the take-home assignment. So we have already done this.
With these few words of mine.
I will convince you. You're not
I thought it was coming. Olatunji Raphael.
Yes, sir.
Thank you very much for these few words of yours. We're going to start off with Dr. Christie, please. Your feedback.
Mr. Olatunji.
Yes, sir. Yes, ma'am.
You have a very good topic, but I think maybe because of what has happened, you were overwhelmed, and then you really wanted to cover a lot of things, and then there was no time. Let me first of all commend you for the good work.
Yes, ma'am.
Yeah, but you didn't really put in some preparation into what you bring into class, because I was careful about that thing. I said that thing supposed to come on a tray.
Okay.
Everything you brought in. and then the way the matching sticks are here and they are not comfortable with it. So the aesthetic value, you didn't take note of that.
Okay.
And your slide, you were talking to this slide, you were not connecting so much with us.
Okay.
So you need to work on that. The experiment was very, very, very powerful and interesting,
Okay.
but you didn't really make use of us or even talking to us. But it's a very good attempt, and I know you'll do better.
Yes.
You understand? Yeah.
Thank you very much, Dr. Christie. Ms. Seraphine.
Thank you. Well done, Mr. Raphael. That
Yes.
was a very nice demonstration. I also agree with everything Doctor has just said. I was a little bit worried. I was worried about the plastic bottle, and in fact, it's also in your instruction that you should place a plastic bottle over a flame, and I thought, wow, safety. That's a safety issue because plastic melts, you know, and as a science teacher, safety has to be one of the important things you're teaching your children. So I would not have said I don't know, is that the new thing now? Put a plastic bottle.
Not at all.
It won't melt. But it's not like that one. That one will melt, but this one won't melt. This one is a thermoset.
I bet.
There are two types of plastic.
Thermoset
And thermoplastic. That one is a thermoplastic.
Okay.
This one is a thermoset.
I just thought that
Okay,
it's probably not a good instruction because they will go and try it at home.
Okay.
And you won't
They
consider.
can go and try it at
Okay.
home. So that was a little bit dangerous. And as a matter of fact, the first step is to talk about safety whenever you are doing a demonstration in a science class. I also felt that your slides could have been a lot more visual, more pictures. You're teaching JS1. These are 11-year-olds, 12-year-olds. They would have done well with seeing pictures. That would have been very, very helpful for their understanding also.
Yes.
And also just to ask them more critical thinking questions to aid understanding. But apart from that, thank you very much for the effort.
Yes. Thank you.
Thank you very much, Olatunji. So you've been told about safety, and we cannot overemphasize when it comes to safety.
Yes.
So without getting into any arguments or to and fro, if I said to you, rather than plastic, what would be a better material to use and have the same effect, what would you say to me?
Now, what happened is that I've gotten a taller container, very tall. So the flame would get to the container up. Maybe like an ivory bottle, very big, so it won't get to the top of the bottle.
When you're in a hole, stop digging.
Okay, sir.
That's the advice. I asked you a clear question though. You go in off syllabus. I said, what other material apart from plastic might you be able to use
So you can use
to
a
have
glass
this?
tumbler.
Thank you,
Tumbler.
simple.
But I could not get a tumbler, so I made do with this one.
That's different, but
Okay.
what you, so you'd explain that, okay,
Okay.
because I didn't have access to a tumbler. I know glass is a safer material. We're talking of safety here. And apart from the glass, anyway, on this type of table, should you, even in the chemistry lab, wouldn't you have something else that you would place, like a Bunsen burner?
Maybe a plywood. Maybe a slab, rectangular slab.
Slab, or what do we call it, tiles.
Okay.
Yeah? So, because safety cannot be, and you just will lighten each match and just.
We're under pressure, so normally I won't do that in a classroom, but being that here.
So just because we're here, we're under pressure, you thought you just burn us up.
No, you won't burn up. I just extinguish the flame.
No, I'm just having a bit of fun there, but okay. But you know what, Olatunji, to get down to it, I don't want to be discouraging, but there's some basics you're not quite doing. Doctor has already told you that you spent more time. I put it down here. I said, looking more at the board. You spent more time talking to your slides than talking to us. The first half of the lesson, you prepared the slides. So all you need to simply do is know your slides, tell us about your slides. Well, in fact, you don't really want to tell us, which is the second point. I just put down telling. There's 21% of oxygen. No opportunities for your students to guess, to talk about prior learning. Okay, remember in the previous class, we looked at the composition. You're talking about oxygen. There's no more oxygen. Where was the oxygen in the first place? I heard no explanation that air is composed out of the different gases or whatever it is you have in the atmosphere. Yeah, because the oxygen you're talking about there would have been, yeah. So you have to just take a step back a bit. What I would advise you to do really is, you've got some very cooperative colleagues. We're running a very collegiate system in the house. I would suggest whenever you have a lesson, run it by one or two of them. Actually teach, because it's 5 minutes, teach the 5 minutes to them, get their feedback. Yeah, especially someone who's not probably science inclined. Get their feedback. Check if they've actually understood. Yeah,
Okay.
and I think that might be the best way for you to go. Again, I can see the effort, I can see the wanting to do well, but there's some basics to teaching, to pedagogy, that you just need to have in place that's going to make your lesson fly and make you connect with your students. That's the reason why, there's this discussion. Is it an art? Is it a science? If you ask me, I would say it's part of both. And you've got to try and meld them together seamlessly, so that the key thing is that the students leave the lesson 5 minutes later, 50 minutes later, having picked up new things, saying, I didn't know that when I came in, and now I know this. And that's when we say learning has taken place. Thank you for your time. I will hand you over to Doctor.
And who will I hand you over to? Olatunji, you talked too much when it is a demonstrable topic. If there is any English word like that. So I think there was too much telling. So you need to work on that. You had your experiment, and your first page, let me see the first page of this slide. The very first page. Yeah. This first slide is just very good. But it says the judges all the questions they will need to ask for. And this is the first time we have something very comprehensive packed together on the first page of this. So when I saw this, I said, wow, this is an organized teacher who seems to know what he wants to do. You have the subject, you have the topic, you have the subtopic, you have the class, you have the date, you have the objectives, you also have the instructional materials, everything in the introductory slide. That's beautiful. Very beautiful. So when I saw this, I said, wow, I'm in for another great teaching. But you see, as you move forward, you slow down that tempo when you started talking and talking and talking. Go to the next slide.
Teacher me, my teacher, my brother.